So what I'm planning to cover today is to talk through how to design a data model that you could use to then answer the kind of business questions that you want from the hack challenge. And actually, it goes back to what Martin and Yoshi were saying in the beginning of the presentation, which is you really need to think about your problem statements and your user stories and get all of that right before you just dive in and start to work with the data, because that will determine what you're going to do with the data and how you need to work with it. There's lots of ways you could work with data. So in order to know how to shape the data, how to analyze the data, you need to know what the business questions that you need to answer are. So we've got a high level challenge statement, and we essentially need to convert that into user stories, problem statements, and key questions. And we'll go through an example. And obviously this is geared towards Power BI, so building a data model in Power BI. And I'll go through an example of how I've done that for some construction activity data. But I think it can also apply across other areas as well. So as you come up with these business questions, you can gear more of those towards predictive questions and things that you could actually answer through using a data science model, for example. So Yoshi, are you admitting people into the room? Because I can see people coming in. Are you admitting them?
Yeah.
Brilliant. All right, thank you. So a little bit of background to myself. So I'm a consultant. I'm principal consultant at a company called Altius. We got acquired by Avanade, which is a large, one of the largest Microsoft consultancies in the world. So we're now part of Avanade. I'm a data platform MVP, which means I'm a community leader. So I do lots of things in the data platform community, the Power BI community specifically. And there's two main communities I run at the moment. So one is called Learn Data Insights, which is what this slide deck is based on. And I think, I don't know if Naveen's in the call, but I run that with him as well. So this is for helping people to prepare for exams and Microsoft certifications. So it's quizzes and courses and games to kind of test your knowledge. So for the main one I'm doing is Power BI, so the DA 100 exam, and also Naveen's doing some stuff on there for the Python exam, so 98831. So yeah, check that out if you're interested. And then the other thing I run is Power Platform Finance. So this is leveraging the fact that I'm an accountant by background. I haven't done accounting in a while, but this is looking at how Power Platform, so Power BI, Power Apps, Power Automate, Power Virtual Agents apply within the finance sector. So we've been running since March fortnightly webinars where we've had vendors come in and speak on Power BI solutions that they have. And also we've had some of my colleagues from Altius and a few other people. So we've got one coming up next week, which is with Bob Duffy on cash flow modeling. So if you go to powerplatformfinance.com, you can sign up to that. And I think it'll be really interesting for people working with project data as well, because it's quite related. There's a lot of project finance stuff that needs to be done for reporting. So in terms of kind of what we're going to cover today, so there's 4 key steps to designing this data model. So the first one is to know your audience. The second is to complete a scoping template, which we'll run through. The third is to find the great data granularity and scope. And the fourth is to conceptually design a data model. And all these templates that we'll run through today are available for you to use in the hacks and obviously in your work as well. So the URLs here, Yoshi, if you don't mind, if you could just put that URL in the chat as well so everyone can have it.
Yeah, we'll do.
Yep, you've got it.
2 seconds. Yep. Just give me a second, I've not got it yet, hold on. Yeah.
Got it? Brilliant. So what I'll do is first, let me just show you the data that we're working with here and kind of what we're looking at. So this is based on kind of a real life example. So we've got, it's for construction project. So a large construction project, and it's procurement of all of the items that we need for that. And it's broken down by work packages. So these work packages relate to a particular set of construction activities. And we can see actually that the work package number is in code. So BS actually relates there to the concrete base building. This is all dummy. I think I made some of this stuff up. But these are all the work packages numbers, the activity types, and then what they relate to. So brickwork and electrical cabling and things like that. So these construction activities relate to these. And then we've got, in terms of the procurement process for each of these work packages. So each of these work packages relates to a number of items which need to be procured. And they need to go through a series of steps. So this is the kind of fairly long procurement process. So we've got, lots of different steps here: design documents, the RFI, the RFP, the bids return, technical evaluation, commercial evaluation, RFQ, and then issue the purchase order. And then we've got dates for each of those. We've got forecast, actual, and planned for each of these. And then at the end for that work package, we've also got a date that it's required on site. So this is the date that we need to have it on our site in order to not impact the schedule. So this is fixed. And then ETA is kind of currently what is the expected time that it's going to be delivered. So the difference between these are essentially the delay, what we refer to as the float in these activities. So we've got this for July, and we've got a snapshot in August of all of these kind of dates that we've got for against each of these activities. We've then got some kind of reference data. So we've got stages. So these are the various stages that we've got. We've got a person responsible for them, and just giving an order number. And actually, this is quite a good thing to have in your data sets, in your reference data tables, because it will help when you come to do visualizations and things like that. Same thing with activities. So say the activities is within the work package code, and we've got a list of work packages here as well. So unique list of all work packages. Ideally, if you are looking at building this data would, rather than it all coming from one big spreadsheet, would come from a reference data source. So somewhere that actually contains your work packages, your activities, and your stages. And the reason for that is because, yes, whilst you could extract the unique list of work packages from this data, you actually want to, you might not have all of them in there, right? So, and you might be interested in work packages that don't have a schedule, that are not in here. And in order to be able to analyze those, you need to have the full complete list of work packages in here. And this goes to any reference data. So ideally, when you're collecting data for this stuff, you need to look at collecting both sets, and your reference data should really come from a master reference data source. So anyway, so this is the data, and I guess the question is, well, where do we go from here? How do we start to analyze this data? There's lots and lots of dates, lots and lots of columns. What could we do with this data to really understand what it is that we want to do? So, our challenge hack might be something like, well, we want to understand delays and bottlenecks or something like that. So where do we go from there? So, so the first, when we need to build a Power BI report, rather than kind of, do we start with capturing requirements? Do we start with doing some data analysis, or do we start with designing our architecture for the Power BI? And I think, the question is, how do you go from that data to a data visualization? And whilst it's tempting to kind of just put data into Power BI straight away, and you can produce some visuals in minutes, and that's one of the real benefits of something like Power BI, that's often the wrong place to start, because you've got data there, you haven't really thought about how it needs to be shaped, how it needs to be modeled, what it needs to do in order to be able to answer questions, because you haven't identified questions. So the best place to start with this isn't necessarily with the data, but actually with the business questions that you want to answer. So we're going to do this starting with user stories, and Martin and Yoshi mentioned this at the beginning of the hack as well. So I just pulled out a definition from Wikipedia. So a user story is an informal natural language description of one or more features written from the perspective of an end user or user of a system. And this is really, really important. So one of the first things you'll need to do with these hack challenges is identify who your audience is for the end output? Who is the end user of this? Is it the contractors, developers? Is it in the example that I'm just starting to work on now, the planning permission? You know, we've got a few different audiences. We've got general public to look at whether their planning permission will be successful, or what's going on in their area around planning applications, or it's potentially the developers, or it's the councils who are granted the planning permission. So identify who those users are and what then they want from there. So let's go through that example with this construction activity. So as a user X, the format of user story is as user X, or as this person, I want to be able to do Y so that I can achieve Z. And this is really important because we want to know who the person is, what they want to be able to do. But this is really important. This is often missed. It's the so what. So what are you going to do with that information? And this will really help to make your reports, your data visualizations, but also anything that you build as an output from this actionable. So, and that's what this is really about. You could, I see lots and lots of examples where people build some really nice Power BI reports, and they think, yeah, this is great. So they put them up, and then initially it gets a few people looking at it, going, oh, great, well done. And then after a couple of weeks, the usage just drops off a cliff, and you'll go into the usage metrics reports on Power BI, and you'll look at no one's really going into it, and you think, well, why? And the real reason is because they haven't thought about actionable insights that people are going to be able to look at this report and do something with that data, because that's what's going to keep them coming back and making this useful for decision making, rather than just being a nice bit of, like a news article that they'd read and think, oh, that's nice, that's good, that's interesting. We really want to have actionable insights out of it. So let's go back to this example. So we've identified two main audiences for this construction activity, for procurement activity. So we've got Mark, who's the project delivery lead, and Jason, who's the operations lead. So Mark, the user story for him is that he wants to be able to identify slippages and project delays. That's at a project level. So looking at that float, essentially, I guess, and identify where their slippages and what the impact of that is going to be. And the reason for that is so that he can mitigate the impact of slippages and delays on project delivery. So that's our kind of user story for our project delivery lead. And then we've got Jason, our operations lead, and he's got a slightly different, I mean, it's very related, but he's got a slightly different view on what he wants to get out of it. And you need to make sure that your reports are catered to specific audiences. So it could be different pages of the same report, it could be different reports, but either way, it needs to be catered to specific audiences. So from an operations perspective, he's more interested in the workflow, in those stages, and looking at the RFP stage or the commercial technical evaluation stages. And he wants to identify where there's bottlenecks across these stages. So how long are things getting stuck at RFP? And are there particular vendors or particular people we're working with at those stages which are causing delays? Are there bottlenecks at those stages? And so he can work with the contractors responsible for those construction stages to resolve the bottlenecks. Does that make sense? Are there any questions on that? Say, feel free to unmute, or Yoshi, there's any questions in the chat?
If you've got any questions, guys, just
echoey there, Yoshi.
Yeah.
Cool. Okay. So that's your kind of first step, right? Which is defining the user stories. The next step is then putting this into a kind of scoping template. So I've got examples to download, which you can do from here. And this is where it's just a high level, it's just a Word document. So it's just very, very high level. So you will need to do potentially some more more detailed analysis, but for something like a project hack, this is brilliant. For a hackathon, this is great. And also for small projects, and actually it's a starting point even for big projects. This is really good because you can fill out one of these from a quick half-an-hour conversation with your end audience, right? Or maybe an hour or two kind of workshop if you want to get into some of that detail. So it's got a few columns in here. So the first one is the user audience. So who is this aimed at? So we're saying, let's look at Mark, the delivery lead, and make sure we name specific people here. And for the dashboard or area, what's the area that we want to look at? So in this case, we're looking at delay analysis. So this might end up becoming a page in our report, or it might end up becoming a dashboard. And then what is the problem statement? And this is really the user story, but really expressed in terms of a problem statement. So he wants to know what has slipped compared to the previous period and where the slippage occurred, so that he can fix it before the impact on schedule becomes too large. And he wants to know which work packages are currently delayed and by how much, in order to understand the impact on schedule and cost. So what we want to do here is really identify the things that are, keeping Mark up at night. What are the things, what are his real problems that he wants to try and solve with this data visualization or this model. And then from these problem statements, we can come up with some kind of key questions that Mark would have of this, right? So, how many work packages are actually delayed? So it's the float, right? What is the float compared to the previous period? How many work packages are delayed at each stage? So what is the last completed stage essentially for those delayed projects, work packages? Which ones have become delayed within the last month, and which stage have they come delayed at? So we're looking at this again from a kind of project perspective. How delayed are the packages at each stage? And then what kind of questions, what kind of KPIs and measures would help to answer those questions? So we've got things like number of work packages, the number of work packages delayed, the number which have become delayed in last month, the value of the work packages delayed, and the total delay in days. Those are some of the kind of measures, if we identify those, will help us to answer those questions. And what would we want to view and filter those by? So look at it by stage, by activity type, by time, and say by delay category. So, we want to break it down into those that are delayed more than 3 months, or 1 to 3 months, or 1 to 2 weeks, because the amount of the delay is going to have a real impact on actually we want to see, especially if we've got hundreds or thousands of work packages, we want to really identify those that have got the highest delays, or ones that we know that we can do something about. And then data sources. So just a very high level, just a one-liner kind of description on what's the data source that would give us this information, that give us these kind of KPIs and measures, and what we could view and filter them by. So we have the list of work packages for each stage and the ETA and ROS date. So ETA date and the required on-site date for each work package. So what I'll do now, again, if there are any questions, obviously feel free to ask, but I'll go through an example of a Power BI report I built based off this data, and tie it back to some of these questions. You can see what this end output might look like. And it's just an example. It's probably, I'm sure there's guys who could do probably a better analysis on this. Spend a bit more time. So I start the report with actually putting that scoping template on there. And I have actually done this in a lot of real examples, because this, when someone's coming into it, they could see this template and they can see delay analysis. I know which questions I'll be able to answer from that delay analysis page and from the stage analysis page. And I know what the KPIs and measures and view and filter them by. So it's almost giving them a little bit of information as to what this report is going to answer. And hopefully these questions are the kind of questions they have in their mind. So if these questions resonate with the people who are looking at this report, that you've got some credibility now in terms of your report, that this is going to be useful to them. So for delay analysis, for example, so we started off, so we wanted to kind of, sorry, I'll just try and flip back and forth. So we want to know kind of how many work packages are delayed and how many at each stage. So we can see that we've got our top level metrics. How many work packages have we got delayed? How many were delayed in the latest month? How many were delayed in a prior month? And then the difference between those is the number of packages that have newly become delayed this month. So now delayed, where they weren't previously. We've got the value of the packages now delayed and the total delay. So this is the total float. So you've got your high level, and the idea behind data visualization is to make it as easy as possible for your users to answer these questions. You really don't want to make them have to work to get to the answer to these questions, right? So it's like when someone's marking an exam, you want to make it as easy for the marker as possible. You want to clearly lay out and structure your answer so that they can tick all the boxes and say, yep, I can see he's done this, this, this. top marks. That's exactly what we want to do here. We want to just make it as easy as possible. Reduce cognitive load is the kind of main aim of data visualization. So that's what we can. That's why some metrics at the top are sometimes really good, because it gives them that information they need straight away. And then simple charts. So again, don't go overly complex in the data visualization, because complex visualizations increase cognitive load. So from here, we can go in and see at a glance how many work packages which have come delayed by category. So how many have had a 1 to 3 month float decrease, 0 to 1 month. Packages which have become delayed by last completed stage. So what stage are they at, where they've become delayed? How many by time category, so up to 3 months. So this is totally currently delayed. So this is the newly delayed. This is all of the ones that are currently delayed. How many are 3 months, 1 month late, all of those. And then how many by last completed stage. And then we've got the details of those work packages here. So the idea is that actually what we could do is use the cross filtering within Power BI to be able to then answer the rest of the questions, because we want to then be able to see, well, how delayed are they overall? And we can start to use these cross filters, say, okay, let me see all the ones that are at the design docs to be issued stage. And so we click on design docs to be issued, and now everything else updates to reflect those. So now we can see all of those ones which are currently at that stage, that work package stage. And we can see the time category, the float, and we can see the details of all of those here. So you can also use things like report tooltips and drill throughs to be able to provide that detail. But again, what we want to do here is make use of cross filtering. So really think about the graphs that you're using and think about how you can go from a high level view into detail. So say there's a few ways to do it. You can either have a table, for example, on the same report page, or you can have report page tooltips, or you can have drill throughs and bookmarks, lots of ways to kind of achieve that objective and to answer those questions. And that's the user journey you should generally think of. When they come in, they should know straight away what the issue is, if there's any issues. So they should draw attention to the things that are going to be important, which is why, again, we've used color here as well. So the red indicates a delay. So it draws their attention. We're not using loads of color. We're using grays and blues to keep things neutral, and then we're using red to draw attention where we think attention is warranted. And same with conditional formatting here. So that's the idea. You start off with a very high level picture, draw attention where you want to draw attention, and then allow people to drill into details and start to understand what's driving the numbers. Is it things at particular stages? Is it things that who could have done personal responsible here? That was one of our fields. Or particular activities. Are there particular activities which are delayed? Are there particular people who are responsible for those stages? Are those kind of stages delayed? So we can start to understand where there might be issues, what might be causing some of these delays. Yep, so that's a screenshot of that. And then this is the second page, which is looking at the stage analysis. And one thing you'll notice with this, so in the stage analysis, is we've broken it down by actual versus planned by stage. So if you remember on here, we had for each one of these, we had we've got planned, forecast, and actual. So actually, this is focusing on each stage and then looking at the difference between the actual and the planned date. So between 21st of June and 13th of May, and then looking at the averages of those across work packages, across the various different stages. So we can start to see at each stage where there's particular delays. So it's in here. So we can start to see actual versus plans. We've got bullet charts. And again, these kind of charts are useful for context, because this is the actual versus planned variance. Actual, and then we've got the planned date there as context. Or you look at the actual delay by stage. So the actual variance number, the number of days difference, average delay per stage. And here we can see the actual versus planned. And again, that's another really important thing with data visualization, is make sure you give context to your numbers, right? So if you just say, okay, there's 300 days delay. Okay, is that good or is that bad? So yep, I can see, a high level total delay, 2,805 days. Okay, I mean, given the scale of the project, the scope of the project, I don't know whether that's good or bad. So you need to give context to that number to say, actually, this is for each stage, this is the planned, and this is the actual. Or, this is the number of delays, the variance. So variance gives context. We've got the kind of S-curves, so the cumulative procurement tasks, planned, actual, and over time. So again, we can break that down by stage. So all the ones at a particular stage, what was the planned and actual for those? How many activities or work packages were planned to be completed at that stage versus overall, so versus actual. So this actually gives you overall, and then we can click on one of these bars to focus on a particular stage. And then we can look at planned and actual by week. So again, we can start to understand where that planned and actual variance started to be driven by. So we can see RFQ approved has a high average delay. And then by clicking on that, we can then start to see when exactly that delay was. So we can see actual for week of 12th, it was actual was 10, and then planned was 7. So yeah, we can start to understand when that delay happened, and look at that from a time perspective. We can look at it from a few other things, from person responsible, from activity types, lots of things we can do here. We've got the activity types as a slicer. Again, we can either use things as slicers, or we can put them into the report visuals. So yeah, that's kind of how we go from questions into data visualizations. So I'm going to go through a few quite important topics, but I'm going to go through them very high level and quite quickly, because the idea is not too much to focus on all of this now, but really I want you to get some of this scoping templates, start using some of these templates in your planning exercises, which you're doing now. So it's actually quite good, Yoshi, that we did this at the beginning of the hack actually. So that was well timed, well done. One of the things we're doing for the metrics. So in here we've got, if we look back on the metric tracking, sorry, the scoping template, we've got our KPIs and measures here. Now, most of these should be fairly obvious. That these are all quite simple, and people know kind of how to measure those. But it's also worth sometimes, especially for the more complicated measures, to actually track a document where you define what these measures are. Right, upfront, define what the measures are, how you're going to calculate them, and obviously in a more commercial environment, who's responsible for that data, how you're going to get that data. So I've got to give another template here, which is the metrics tracking template. Actually, I've got it open in Excel, I think. Metrics tracking. Sorry. So here we've got the metric name, the area or the domain, who requested it, the user story that it relates to. So we're tying that again back to our user stories, the definition of it. So in English definition, so the number of work packages which delayed with an original scheduled end date within the last 30 days. Distinct count of work package ID, where the float is less than 0. So here's the kind of formula. So you don't need to write this in, a DAX or anything like that. It's more kind of English formula, or you could use, Excel function type things which people understand. But distinct count of work package ID, where float is less than 0 and original end date within the last 30 days. The format, the data source, the frequency of update. So this is useful to track against your metrics. Again, obviously for hackathon, slightly less relevant. But who the data owner is, security you need around this, and if there's any alerts. So one of the functionalities of Power BI is you can set up alerts for things, for example, and you can set up row level security. So two people could go in, look at exactly the same report, but we'll see different numbers depending on their role. So yeah, we've got metric tracking. Again, that could be useful to draw out some of that detail on the metrics that you want to track. We've then got, so that's your kind of scoping. So complete a scoping template and metric tracking. That's your second step. Any questions at this point?
Let's have a look. No questions in the comments. If you've got any questions, guys, just come off mute or put in the comment section and we'll read it to Rishi so we can answer them.
Yep, it's yeah, it's really good to get some interactivity and get some questions on this. Obviously, feel free to reach out to me afterwards as well. So the third step, cool. Yeah, so we did the first step, which was looking at the user stories and know our audience. That was our first step. The second one was to define a complete scoping template. So identify those key questions that you want to answer from the data visualization, and hopefully I've given you a bit of an idea as to how that might look in an end data visualization. And you don't do that exercise blind to data. You look at the data so you understand the kind of questions that you could get from the data as well. So whilst it's not a data exercise, you're kind of doing it with a view of what kind of data you have available and what kind of questions you want to be able to answer from it. And then from here, now we go into some real detail about the individual data sets. And we look at how we need to shape that data in order to be able to answer those questions. So we look at the data granularity and the scope of data. So it's how do we go from this massive kind of spreadsheet of data with all these columns and all these dates into a data model. So we need to kind of categorize it and understand it. And the way we categorize the data, and this could be categorized by data tables or indeed columns that we can kind of categorize. And we could do that by looking at it in two types of field or tables. So ones will be, and these will be tables in our data model. We'll have two types of tables in our data model. So we should have dimensions and facts. This is based on kind of Kimball data modeling techniques, which is the real technique recommended for modeling Power BI data or analysis services data. So dimensions are your business entities. So even if you're looking at a long spreadsheet with lots of different things, think about what are your business entities. So in a sales example, it might be things like dates. Dates will always be a business entity if you've got any kind of date fields in there. So dates will always be an entity, essentially a dimension that you'll have in your model usually. In the sales example, you might have things like customers and products. In a construction project example, you might have things like work activities or people, or people responsible, contractors might be an entity. Because, and what differentiates a business entity, a dimension, from just a descriptive field is that ideally this will have multiple attributes. So if you have contractor as a business entity, then you have your contractor tagged in your data, and then you can have a separate reference data table, a business entity dimension table for contractors that has details of all of the contractors. So what's their information that's relevant to reporting on the contractors. So when do they come on board, how many people do they have, how many staff do they have, what's their pricing range or their commercial model or something like that would help you to then be able to maybe slice and dice by. So you can say, I want to see all the people, I want to see all the work activities that are happening with contractors that have a commercial model of X. So that's how you need to think about your kind of dimensions, and they have attributes. So every dimension table has columns of attributes. So if we're thinking of dates is it's a very common dimension, and it has attributes. A date has an attribute of day of week, which month is it, which year is it. So all of those are attributes. Say contractors, we've got another example there as well. We've got then dimensions are the things that you slice and dice by. So the things that you have on the axes of your charts or rows and columns of your tables. And so we want these to be as rich as possible. The richer your dimensions are, the richer you can get reference data and master data for, the richer your analysis will be able to be, because it will give you more things to put on the axes of your charts and slice and dice. So you could look at delays by contractor, by person responsible, by time, over time. So all of these things are really important. And the idea is you have in the master data that you get for this, your reference data, you have one row per value. So in your calendar, your date dimension, it has one row per date. In your contractor dimension, you have one row per contractor, and it gives all the attributes of a contractor. So it's not very many rows, and it might be lots of columns, and lots of columns is not a problem here in your dimensions because you haven't got many rows, and it gives you richer slice and dice capability. By contrast, then you'll have fact tables. So these are the tables that are going to be part of your they're going to be repeated dimension tables. So this is going to be your actual numerical data. So the idea is you can have one or more fact tables, and you should have as few as possible, because these are going to be quite big tables essentially. So they're captured as part of a business process. So that business process might be, an RF procurement process, or it could be a particular process that you're going through in the construction activity that you're tracking. So it could be, the process of tracking COVID-19 incidents or something like that. You've got a business process that's happening. For sales transaction, it might be the sales price and quantity purchased that you get numerical data points captured. And these numerical data points should be additive. So for example, sales amounts, where it's meaningful to add values together. You might have other things like balances or prices and things like that, which are also numerical, but it doesn't really make sense to add them all together. So for those, you need to think about a different way of dealing with those. And some of those might just feature in price, might end up being, for example, one of the attributes of your dimension, because for the product, you might say it's an expensive product or a cheap product. So you might have different ways of dealing with those. But in your fact table, you want to make sure you have some numerical additive values. Make sure they're directly relevant to the business process. So the fields, the numerical values in here should be directly relevant to that business process and should be at the most granular and transactional level. You can always roll stuff up in Power BI, and we'll look at architecture in a minute where you can think about aggregating your data, but it should be initially identified at least at the most transactional granular level that you can. And the idea is that these fact tables are calculated for a given combination of dimensions. So for a sales transaction, you'll have the sales quantity and you have the sales quantity purchased and the total amount purchased, and you'll have that by your different dimensions. So it'll be a particular process as someone's walked into a store and bought a product. So you have the date captured as part of that. So it'll be captured against a particular date, might be captured against a particular store, a particular salesperson, all of these dimensions. So again, you can think about this for your examples. What does that look like? How would you break that down into what are your numerical data points, and what are you looking at those data points by? And these are then, if anyone's familiar with kind of modeling, this is where you're going to create your relationships in a Power BI data model, for example, where you have one row per value here, and then those dimension values are repeated in your fact table. So you get the one-to-many relationship between your dimension and your fact tables. And one of the ways we can start to take that data and almost categorize it or understand which tables we have or which data points we have by which dimensions or which grain of dimensions is something called a bus matrix. And again, I've given an example of a template here. This might be a little bit overkill for what you're trying to do for this. Generally you're working off, but actually, I mean, if you're working off different data sets, it'll be really helpful, because what you can do is have, and I'll open up an example of a bus matrix. If you look at this online, you might find a slightly different example. I've kind of bastardized it a little bit in my example, but what I've done here is I've put, then you have all of your tables in here. So where you've got lots of different data sources that you're working on, you can have the data sources in here. So it'll be, I'm working on this procurement data set, and it's got these, and then these are the numerical data points that you've got. So you can track down all the numerical data points, and then here are all the things that you have those data points by. So by date, so you can, again, a date's going to be, say, a common one. And you can use this as kind of a starting point, but any kind of date fields. So here then I've listed out the fields or the attributes essentially of those. And then do we have these numerical data points by this dimension? And we can see that potentially we've got all of these, because really here we're working with one large table. We've got all of these kind of numerical, and in this case dates, but dates are numbers. We've got these numerical values by date. We also have them all by work package, and we have them all by activities. So what this will allow you to do is see what kind of attributes you have. And actually, you don't want to have all of the fields. So, these might come from the same table, or might come from different tables, and it allows you to identify which ones you potentially want to focus on. So I've also used some color coding here, not in this particular example, but where you can actually say, these are fields that we want to bring in. So these are the attributes that we care about in order to answer our business questions. It also allows you to understand how you want to potentially shape or combine the data, because where you've got multiple measures all by the same set of dimensions at the same granularity, then you can combine them into a single fact table, even if they're different data sources in your model. So you might have two tables that you can combine into one, or you might need to keep them as separate fact tables if you've got different sets of dimensions that you want to analyze them by. So this allows you to really kind of look at that data and start to split out some of your columns into how they're going to be used in the data model. Are they going to be part of a fact table? Are they going to be part of dimension table? Then how many fact tables are you going to have? 1 or 2 or 3? And then which ones can you then have in your dimension tables? And I'll show you what that looks like in a minute in the Power BI data model. This was just an example I put in here as well around actually think about the level of granularity of your data as well. So this is an example where I was working with some New York City taxi trip data of 2.3 billion rows, and we have data for every single trip around, you know, the longer latitude of drop off and pickup, you know, the exact time, the rain in inches at that time, the sun temperature in degrees Fahrenheit. So very, very detailed data, but that detailed data might just be noise, because actually, do you really care about whether it was 73 degrees Fahrenheit or 73.5 degrees Fahrenheit? Probably not. If you're looking at this and your audience is, you know, potential taxi drivers who want to buy a medallion, you're kind of looking at number of trips and, you know, what your fares and that you could get on a hot day versus a cold day, or, you know, in a time bucket rather than the exact time. So actually you can start to think about how you can aggregate the data and group the data to make that analysis more meaningful, and also reduce the number of rows, because bringing in 2.3 billion rows of data is going to be hard to make it hard to work with, especially when you don't need that level of detail for your analysis. So what I did with this example was aggregate it. So I just brought in rain categories. Is it raining or not raining? Is it hot or very hot or cold? So temperature category. And then didn't bring in the individual rows for those. So I did some pre-aggregation of the data. So again, passenger count rather than number of passengers. Didn't bring in longer lats, just brought in the country zip code. And it got down from 2.3 billion to 1.8 million rows. So I don't think you've got any of these kind of data size volumes that you're working with in a hackathon, but again, worth bearing in mind for large scale commercial projects that you're working on, especially. And then the last step, which kind of brings this all together, and is designing a data model. So based around thinking about what your dimensions and facts are, what your business questions that you want to answer, you bring that all together for to bring it into a data model. How are we doing for time? We've got a few minutes, right? So the idea with this is that this is what's called a Starnet. So it's a kind of documented thing where you can plan this before building your data model, because this is essentially going to be the blueprint for how your data model is built in say Power BI with a query editor. So we've got, and we have a circle, and in the middle of the circle we have our kind of key measures. So we have number of work packages. We have some of the numerical values that we have in there. So that's kind of, we draw a circle, put those in the middle. And then we have the branches coming out of these, which are basically our dimensions. So here we've got then work packages, and we're looking at the ETA, the date, the ROS, and the float, which is the kind of difference between those two. And we're looking at it by work packages. So this is one of our dimensions, and we've got in there work package number. We've got activity, and activity here is shown as a circle because that's actually a hierarchy in itself. Under activity, we've got activity detail, person responsible for activity. We've got other details behind activity. So that's a hierarchy. And then we've got title of the work package and the cost of the work package. We've got the current last completed stage. So these could be things that we can either add as calculated columns, for example, for the data set. And we've got float delay category. So again, this might be a category where we say, is the float delayed by a delay more than 3 months, 1 to 3 months, 1 to 2 weeks, and so on. And then we've got date. And the date we've got in here, so the date we've got in the first column of our data set is actually the data extract date. So that's what the date is here. If we have a look at the data, that's this first date column here is the data extract date. And then we've got against all of these, we could have put all of these in there. We've got our ROS, our ETA, and we've got then the stages, work packages. So we've got the work package number. So that's kind of how that looks. And then if I show you how that looks in Power BI.
Good question, Rishi.
Yeah.
Question came in from Shane. What did you use to get the NYC taxi data down to 1.8 million?
What did I do to get it down? So I aggregated the data. So it's a group by. So you could do the group by in SQL or in Query Editor. So I said, and a kind of mapping, right? So I think in this particular case, I said, if rain inches is greater than 0, so case when in SQL, case when rain inches greater than 0, then raining, else not raining, as rain. And then I didn't bring in the actual column for individual rain inches. So it's a group by on those. Does that answer your question, Shane? If not, feel free to come off mute.
Yep.
And then and just looking at kind of whether you need the data at that level of granularity. So I didn't need individual long and latitudes, right? The country or zip code or area is enough for me to be able to do the analysis on it here. I do have a demo on that actually. I'll put a link to it if you like on the chat. I've got that New York City taxis. I've talked about aggregations. So where you've got a mixture between import and direct query mode for that data. So I'll send a link to that video. So we've actually got two fact tables here, and I'll come back to the second one. But this is the main one. So procurement data. So this is essentially I've brought in all of the data. I don't think I needed to bring in all of these columns. So I brought it in for kind of completeness here. But essentially what I needed to bring in here, the analysis I need to do on here is extract date, work package number. And then the main things I'm interested in is the ROS ETA. And then I've got some calculated columns. So again, I can do these in the query editor. I can do them in DAX. I think I've done some of them in here. So last completed stage. So which is the stage that is currently at, essentially what is the last completed stage. What is the float, the difference between your ETA and your required on site. And then float time category. So again, this was one of the things that we identified that we want to be able to do. We want to be able to have a category that has that does the category for the floats here. So we've got more than 1 year early, 6 months to 1 year early, and then we've got a start and end days. So we can do this using some built-in functionality into Power BI. We can do grouping and binning. So we can take that float number and we can say I want to bin it by 30 day intervals, and it will do 30, 60, 90, and it will show you how many are in each of those. What I've done here is actually just brought in a kind of mapping table, if you like. So this table is a reference table to then say how many have you got. If it's between -180 and -91, it's this category. And then I've used a calculator column in here to be able to calculate that. So I'll show you the formula for that. Float time category. So it's looking at filtering that disconnected table. So this float time categories is just a disconnected table, just a lookup table essentially, and it's performing the lookup to say filter it down to where my float is within the before the start date and before the start range number and before the end range number, and then filter it down to return the actual float category. So that's where it then returns the category there. So it's kind of like a relationship, but you can't do a relationship against a start and end point. So it's kind of a pattern to extract the category. So it's basically like doing a VLOOKUP in Excel with 1 as the end parameter, or match with 1. So I can't remember which one it is. VLOOKUP with true or match with 1, where it looks up against categories and buckets. Then we've got the sort order for that. So I've returned the same thing with the sort order. And I've returned some other things in here around, that's it. So those are your kind of calculator columns on there. But the way we identify that we need those calculator columns is by looking at the business questions and by looking at designing the data model to say in this table we need these. Now, this was relatively simple, but actually the second example where we wanted to look at the stages was a lot more complicated, because what we essentially need to do is we can't have, so we've got all of these estates. So if we have a date table, so I've got a date table here, and we've got date one to many against your extract date here, and we've also got work packages and stages. Yep, so stages just links here into last completed stage, because we can then slice and dice by stages. So these are our dimension tables, work packages, stages, and date. And then we link those into a one-to-many relationship to our kind of fact table here on procurement data. So that kind of works. We identified those from our bus matrix and then from the Starnets. But for the second one, right, so then we think about how we do the stage analysis. And for the stage analysis, this is where it gets a little bit harder, because we've got planned, forecast, and actual for every single one of these, and all of these are dates. So essentially what we could do is create, either we'd have to have, 50 copies of our date table, one for a date table that could link one to many into design docs complete plans, because there could only be one active relationship between any two tables, between our dimensions and our facts. So we could have 50 relationships for every single date field in here, which is what that will do almost by default if you enable the time intelligence function in Power BI. So it's a good idea to turn that off. Or what we can do is have one date table and then have inactive relationships to all of these dates. Right, that would be another way to do that. And then you can in the measure you can say, right, I want to look at design docs complete planned. So in a measure, I can do use relationship of date to design docs complete planned. So this is kind of what we've done here, where we've said you've got two inactive relationships, and then in the measure we can activate that. So you can see here's the dotted line. So I wouldn't be able to make both of these active, because you can only have one active relationship between two tables. But actually, even doing that, to be honest, in this case, wouldn't really help us, because what we actually really need to do is unpivot all of this data. And the data format we want to end up with is something like this, where we've got work package number, stage. For each stage, what was our plan date, forecast date, and actual number. So here, work package number is now repeated multiple times. So we've unpivoted the data. We've taken one row per work package, which is our starting data set, and we've done it for 20 rows per work package number, one for each stage. So I think, for example, and so for each work package, we've now got 10 rows, and then for each, there's 10 stages. So for each stage, so then for each work package number for each stage, what was the planned date for that work package at that stage? What was the forecast, or what was the actual? And then we've got some other things around what was the last completed stage, and then we've got the actual to plan variance, which is just again the difference between planned and actual, and the variance time category. So again, we've done a float variances. We've got a lookup table and the same pattern where we've said, is this stage for this work package? What's the difference between your planned and actual? It's 1 month late, 6 months early, on time, and so on. And so it's a little bit of work to get to that. So in terms of, let me just show you very quickly. So I know I'm running a little bit over on this. But in terms of how I actually got to those, it's a lot of unpivots, right? So basically what I did is I remember when I did this, I took one example. So I just did one thing where I connected to columns, and then I unpivoted all the rest of them. So I unpivoted them one by one. And actually what I did was created the code, I think in Excel, to actually just substitute these in. So then I can just copy and paste in all the code, and I don't have to redo all of these steps for every single stage. So I did some things here to make this easier, but essentially what we did was unpivot all of the things separately and then combine them. And then what you end up with is unpivoted data, where you have a work package for stage, plan, forecast, actual. So this now is much more useful format. So then I've got it linked in here. I still got two dates, so I've still got actual and planned. So I've still used that pattern where I've got inactive relationships that I activate when I want to use the plan date. So I activate it for plan date, or if I want to use the actual date. But that's much better than the model of having 10 or 20 relationships to every single one. because also this allows us to have stage as a column, which we can slice and dice by. And that's really what we need here, because we want to have it on the axes. We want to have stage on the axes of our charts. So in order to get to this point, we really need to think about the data model, which is where this really comes back to here, because we have these Starnets that we could look at. We can say, okay, so the Starnet for, let me just open up the Starnet for that second procurement task. So each fact table will have its own Starnet. So here we've got two Starnets because we've got two fact tables. So this planned forecast actual date and variance, it's broken down by stage. So what the stage is, what the planned forecast actual date is against those, against work packages, the variance category, and the planned and actual date. So in order to understand how to get to this point, though, we need to really think about this and design this data model. If we had just put this massive spreadsheet of data into Power BI, so it's not that one, it's procurement data. If we had just put this massive spreadsheet of data into Power BI and then started to try and create relationships, or started to try and model the data and build measures on top of it, we would have got ourselves into a bit of a mess. And this would have been really hard to really draw insights out of. So here, by designing our data model up front, we can then also go back to the scoping and say, actually, from this data model, can we answer these questions? So how can we answer these questions from this data model? Can we look at, will we be able to answer the question of which work packages have come delayed within the last month? Yep, because we've got it by date and we've got it by stage, or whatever it is. So we can go back and really start to look at how we can answer those business questions. So this is the kind of planning activity that I think will be very useful for you to do as a start in, as you go now into the hack. That was all I had, Yoshi. So yeah, it took the full hour there actually, rather than 45 minutes.
No problem. No, it's great, Rishi. Thank you.
No worries. Any other questions?
If you have any other questions, guys, come off mute and let Rishi know.
Yeah, I've got a question.
Sure.
It's Mark. Yeah, thanks, Rishi. Really, really interesting talk. So we're just at the start of this journey with starting to use Power BI in our business, and
Sure.
we're starting to get some useful stuff out of it. But we have taken the wrong approach. I can see now, in terms of we've just tried to start using it without going through this proper modelling. I was interested at the front end, when you're doing this process, would you advise getting when you mentioned the different users, would you advise getting some of those users together in workshops and getting them to talk through exactly what they're trying to get out of this from a business needs perspective, and then try and summarize that on the type of templates you've got? So have a number of those workshops, and I guess the key is to try and get the right people at the right levels in the business. And would you kind of, I don't know, maybe it's too detailed question, but would you look at having those people, different types, all together, or would you look at doing them separately, or trying to do a mix? I'm just trying to think of the number of workshops we'd need to do to try and get this.
Yeah, I mean, look, you ask 10 people what they want and you'll get 10 different answers.
Yeah.
Right? So and the point is that don't focus on what they want to see in a report, right? Because people will have different opinions on this. People will just point you to reports they've done before in Excel and things like that and say, this is what I want to see. And everyone will have a different view on it, right? So, and that's, I've been there so many times, right, where I've done this and asked people, and this is why now I don't ask people what they want to see in the report. I try and have the conversations about what they want, and then across the audiences, I come up with some kind of key questions, right?
Okay.
That come out of the conversations that I've had with them. Yeah, and obviously for the hackathon, you can do this hypothetically because you just put yourself in their shoes, right? Yes. And to be honest, in some cases, I've just put myself in customer shoes and done this myself, rather than even having the workshops in the first place. Not that I'm advocating not to talk to the customers who are going to use this, right?
Yeah.
But yeah, at this level, it should be fairly straightforward to get these questions, right? And then it's your job as a report analyst to be able to understand how to storyboard it. So what kind of visuals are going to answer those questions to get the story across to be able to do that. And your job to turn that into a data model.
Yeah, yeah.
Rishi, that's really interesting. So what you're saying is you create user personas for your data sets and then go away and work out what you're looking for.
Yeah.
So you normalize the different individuals into a persona, and then you work from that way. That's really cool.
Well, I mean, they should be specific people.
Because people are opinionated.
Yeah, people are opinionated, but they should be specific people with specific challenges, right?
Mm-hmm.
But yeah, absolutely. You can talk to people and understand, but I do it at that level. Right? I see a lot of workshops where people spend hours talking about whether they want a line graph or a bar chart and what they want to show, and actually, there's 10 different people. Yeah, let's say 10 different people have 10 different opinions on that.
So you're going the Apple approach. People don't know what they want. Let's just build it for them.
Kind of, but it's more thinking. They'll know what they want because they'll know what their problem statements are. And they'll know what questions they want to answer from it. Right, but it's not really getting them. It's not getting them involved at that level of detail in terms of what visuals do they want to see on the page. It's doing it at a higher level to say what are the key business questions you want to answer, and obviously doing that with a view of data as well, so that you can then combine, think about how you'd answer those questions with the data that you've got.
Rishi, thank you. I think that was really excellent advice. And one of the observations I've made over the last number of years as people begin to build their reporting analytics in Power BI is as soon as they've achieved something in one period end or month end, changes the next period end, and they get very frustrated about that. And part of that problem is exactly just as you've described, is they get to grips with building a model in a certain way because they know the inputs and they know the widgets or the outputs or visualizations people want, but they never stop to think about what really are we trying to solve in terms of information.
Yes.
And without that, and it's never documented, this is my experience, it's never documented, so nobody really has a clue of the real metric or driver that they're trying to respond to. It's fluid. I don't want to call it haphazard, but it's more a fluid, evolving process all the time. And the structure you've proposed, I think, is really useful and really helpful for our community. So thank you very much.
Yep, that's great. Yeah, I mean, so I think, thinking about this from a Power BI implementation perspective, what you wanted, I don't know if you guys are how familiar everyone is with Power BI on the call, but where you want to end up at an enterprise level is to have shared data sets and data flows. And so shared data sets, the idea is you actually build data models that have no visualizations in them. So you build PBIX files that have no visualizations. All they are is the data model, because the idea is then this is how you enable self-serve analytics. You build data sets that can then be used for multiple reports and different audiences and different questions. But the data behind it is still managed from a centralized data model, because if you build your data model well enough, it can start to answer lots of different business questions and different audiences. And each audience and each report will have each audience will have its own reports or set of reports, and each set of reports will be in a different workspace, and they can be distributed that way. But your centralized data models is what you build, is what you should aim at, because then you've got a central single version of the truth. So from a governance perspective and from a consistency perspective, that's what you really drive.
Thank you.
Does that make sense?
Absolutely, perfect sense to me.
Cool.
All of us are on a journey towards that in various different stages of that journey.
Yes. Look, I work with a lot of organizations where I see this as well, where Power BI is great, and Microsoft have this whole story of 5 minutes to wow, which is just because you can build a model in Excel in 5 minutes doesn't mean you should, right? Yes, you can do stuff, you can get some really high value out of stuff really quickly, but then taking that time to go back and plan it and design it will start to drive your analytics journey in the right way. So you don't end up with Power BI hell in exactly the same way you have Excel hell in an organization where everyone's just got millions of spreadsheets floating around, all doing their own thing.
Agreed. Thank you.
Cool. No worries.
Excellent. Got a quick question for you, Rishi. I think it was from Jamie. Can you give your links to the events you mentioned at the start and any links guidance for Microsoft accreditations?
Yep. So I'll just put that in the chat there. So the learndatainsights.com, that's the one I'm doing with quizzes, and then powerplatformfinance.com is the webinars that we're doing for kind of finance sector. So looking at how Power Platform applies in the finance sector. And if anyone has any ideas on this stuff, let me know, by the way, as well. We're kind of going through a process at the moment where we're really thinking for 2021, how do we want to do this? And, 2020 has been one of those years where it's just been, we've put stuff out virtually and we've tried to, do what we can. And now we're really starting to think like, actually, it's going to be the same next year. So how can we drive engagement in the right way? I'm sure all you guys are doing that as well. Obviously, in every community, I think it's the same story, isn't it?